Hi, everyone, and welcome to episode 5 of the EdTech Spots STEM in Education series. For those new viewers, my name is Jelani Payne. I am a STEM educator and advocate and a multidisciplined engineer. I've had the opportunity and pleasure to work with local schools and institutions, like the St. Michael's School, for example, as well as the Caribbean Science Foundation. I'm also the head coach of Robot Adventures, which is a 100% online STEM robotics program. And I'm also the author of a college survival guide called Survive, Thrive, and Stay Alive in College. And you can actually catch this on Amazon. You can see it in the link in the comment section. Now, I'm very passionate about the topic of STEM in education. And today, I'll be both your host and your presenter. Now, our focus in this episode will be on the use of robotics within traditional and non-traditional STEM subjects. I guess you guys can tell I'm very pumped. All right. So if you're now hopping onto this stream, we want to hear from you in the chat. We want to hear from you in the chat, and feel free to state your country, your profession, and social media handle. There is also an opportunity to provide feedback. Now, on this and previous shows, using the feedback link that will be posted in that chat. So if you're interested in being a part of this experience, let us know in the feedback form, and we'll be happy to provide any assistance and discuss this further with you. So let's dive right in. So what we're going to start with is, what is a robot? Well, a robot is a machine, and it's usually powered by some type of electricity, okay? And the third part is it reacts and communicates with its surroundings, okay? That's usually one of the main criteria for something being a robot, all right? And then, of course, it's programmed. It's programmed to perform specific tasks, specific jobs, to do specific work, right? Okay. Now you have some different examples of a robot here. You have like a personal example here where you can see something that looks like, what would be a Roomba, right? That's the one that I know or that I've heard of most. Yeah, but you actually have lots of different manufacturers making those vacuum type robots. Really cool, right? Commercially, you actually have robot bartenders. I don't know if any of you have ever been on, for example, Royal Caribbean's cruise line. Some of their higher cruises, or rather higher end cruise ships, actually have on robot bartenders in the form of what they call the bionic bar. It's something that I would love to experience in the very near future once everything with this pandemic has come to a close. And then, of course, you have the educational part here in terms of an example where you introduce students to the design process, you introduce students to power and electricity, to programming and coding. Now, you know we don't usually get into that so early, but we just give you a taste of what it is going to be about. All right, so when it comes to robots, you have a few different types of robots, and you can look at them as movement-based or control-based. Now, when it comes to movement-based robots, what you're really talking about is you're talking about, for example, driving robots. That is, robots with wheels, okay? And then you also have robot tanks, right? Rolling with tracks, or rather, I should say tracks. And then you have walking robots, okay? Or even balancing robots like we have here, this nice red one, all right? Or even this one here, like I said. You also have flying robots. So those would be like the drones that you see. Some are what we would call autonomous, but we'll get to that. And we also have stationary robots. And you're going to get to see a bit of that as well. And then we can look at robots in terms of types as being control-based. Control-based meaning that they're tele-operated or remote controlled. And of course, then we have autonomous. That means is they sense their own environment. You don't have to do anything except turn them on, make sure that they are charged and ready to go. That's it. Okay? Robot design. Now, when we're talking about robot design, what we're really talking about here is we're talking about structure, right? Or the components of the robot, so structure. So as you see in the first picture, you have that base, that structure. Okay, so that's a tank structure. Then you have power. So in some of our social media that our social media coordinator has been so kind and generous enough to put up on Instagram and so on for us, you would see that I actually created some battery holders for some robots, right? This was especially during the pandemic lockdown right here in Barbados. So there are some lithium ion batteries, and I'm there testing them to ensure that the battery holder is working correctly. So that's the power side of it. And then you have the programming. So programming is just code, right? Um, Coding is a part of programming. Sometimes people get those mixed, right? Um, but there you have it. Your main three parts of your robot design. Now, some advantages of robots. Because persons might be asking, well, Jelani, what's the point of a robot? Who cares? Why do I need one? What's the point? Well, some advantages or some reasons that you might need a robot would be to complete boring and repetitive tasks. Now, I don't know about you, but that kind of sounds like all my schoolwork. Just saying. Um, Increased accuracy over humans, right? Um, So you find robots can actually do those same boring tasks in the exact same way each and every time. Robots don't need sleep; they just need power. Once they have power, they're good to go. Unless you find, let's say, one of the components breaks down or has an issue, they're good to go. So they don't need breaks and they don't need to eat food except for the power or the electricity, I should say. And another final advantage is that robots can actually complete tasks that are too dangerous for humans to do. So one of the things that I share with my students a lot is bomb disposal robots, right? Very cool. Or you can even have robots, for example, doing inspections. In fact, that's what a lot of drones are used for. Yeah. Um, so that gives you an idea of some of the reasons or the advantages to have robots. Now, of course, every time we do a STEM in education episode, it wouldn't be complete without careers. So speaking about careers. So we have computer aided design and drawing. Now remember we spoke about this in episode 3, but that's a big part of robotics because you can design your own components. In fact, we'll actually mention a bit about that later on. You can be a 3D printing technician. Remember we said in episode 3 you can actually print so many different types of materials. We're talking from wood type materials to carbon fiber to metal to concrete, sand. It's crazy. So given all of that, you can literally create anything, right? Okay. And that comes in handy with robotics. Like I said, with the structure, it allows you to actually bring in parts of a robot or components, right? Okay, then you have manufacturing. Now, years ago, I thought to myself, because I studied manufacturing, and one of the main thoughts I had was, huh, a manufacturing plant is like one big giant robot. Every piece of machinery feeds into another, and it has to do so on a specific schedule, on a specific time. It has a specific structure, right? Um, it has a particular layout. It has to run on time. Okay, it's designed to do repetitive tasks. Okay, and that same type of programming, that same type of structure, that same type of power, which all make up the elements of a robot, are in manufacturing. Then you have engineering, biomedical engineering, which we're going to talk about. One of my most interesting things to research is biomedical engineering. You have electronics. Some of our guests are into electronics. Um, we have electrical engineering, electromechanical engineering, and mechatronics. And some of those, or rather those last two, are areas that universities recognize are becoming more and more of a trend. So lots of universities are getting into them. Those tend to be either newer universities, yeah. And then you have computer science, all right. And of course, there's entrepreneurship, right? I mean, come on, if you think about it, there's so much that goes on in terms of creation, in terms of development in terms of robotics that you can actually create your own business. You can create your own companies. In fact, lots of the companies that are being created that persons might say have these high valuations are tech companies, right? And some of them are robotics companies. So robots and robotics in education. Now, when we talk about robots or robotics in education, we're talking about structures and development. Now, let's go to the development part first. Robotics helps students a lot in terms of their creativity and their imagination. Like I said, given the types of careers that are possible, given the types of things that we can do with robots and in robotics, then there's so much creativity to be had. There's so much imagination that can be pushed. Yeah. Then you have problem solving. Now you get students into robotics early from the primary level, and you begin to create and develop students that are problem solvers, right? So okay, let me take a step back. If you're at a primary level, let's say you're a primary school educator, right, or even a primary school student, one of the useful things is if you know how something is created or rather designed, how it works, you have an idea of it, then you're better able to design solutions. Why is that? Well, because now you can take what you know and you can apply it to what you don't know. All right. So by applying it to what you don't know, now you can say, okay, well, for example, if I know 3D design, hey, you know what? I don't only have to just print something from Thingiverse that someone else created. I can design something on my own in Tinkercad and create something, right? So now you can solve a problem, okay? You can solve a problem based on what solution or how you want to solve it, which is a solution. Robotics or robots then push and foster inquiry-based learning, right? So you're forcing, or rather, let me not say forcing, but you're pressing, you're gently nudging. Imagine an educator, you have your hand in the small of your students' backs, and you're gently nudging them towards being more curious, asking more questions, figuring out how things operate. And then project-based learning. I love a good project. You see, a project is better than an exam. Why? A project doesn't just test skills that you can remember. It tests your ability to want to solve the problem. It tests your tenacity, okay? It tests your critical thinking. It tests your problem solving skills, right? It tests your imagination, right? Love it. Then you have hands-on learning. Some persons are those types of learners, right? They may not be learners who learn by just purely reading or purely listening, but they might like to touch. Okay, they might not just be visual, but they also like to touch, they like to build, they like to destroy. I'm like that. I like to, decreate, or as one of my students' mothers like to say, her son likes to repurpose things. So I like to, pick it down. How is it created? Um, Communication is very useful here when it comes to doing robotics and using robots within education, because now students have to communicate with teachers have to communicate with students have to communicate with other students. Get it? It's awesome. They have to talk, they have to communicate, they have to learn from each other. They'll quickly realize, well, where my strengths lie, where my weaknesses lie, and learn to either depend on others, and depend on others either fully, which isn't the best thing, or depend on others to the extent where they recognize, you know what, I actually want to know this myself, so let me jump in. All right. Teamwork. Excellent for teamwork. Excellent, excellent. Now remember, like I said, a robot is made up of, you have the structure, you have the power, or the electronics, or the electrical system, and then you have the programming. Right. One student doesn't have to be great at all. They just have to know one. And then the thing is you'll find that by one student or each student knowing one aspect really well, then that's the future basis for careers, or that's the basis for really developing a strong team, because everyone has to rely on each other, right? Um, So that's the basis of robots or robotics in education. Wait. I forgot structures. Structures I find are in education tend to be clubs, camps, and competitions. Okay, clubs. You can run a club. You can run a club in different ways. And I have been a part of a club, for example, with the St. Michael's School. Is one that I facilitate, and I'm very interested in facilitating clubs at other schools in Barbados. I would love to get calls and assist them in really developing and building out that structure within the various school systems, public, private, it doesn't matter. Even persons who just want to start their own private clubs, camps. I've been a part of the Caribbean Science Foundation's camp for approximately, well, I mean, this is going on 3 years, but let's say 2 years because we weren't able to have camp this year. But what is cool about it is it's a very intense camp, right? Lasts about 5 weeks. I should say 4 because week 5 is really focused on our final showcase, showcasing what the students did, everything they've learned, everything they've built. And you'll get to hear some of those students that I would have worked with later on. They're some of our guests. Competitions. Competitions are great. Why? No one likes to lose. Again, no one likes to lose. So because of that, you get persons competing really fiercely. To compete fiercely, you have to gain more knowledge. Okay, you have to study more, you have to research more, you have to depend on your teammates to do their own research, to their own knowledge, okay, and to assist you, right? So everything is interwoven and works really well together. Roadblocks. This is an area that Jonathan, who has run away to Mexico, I'm kidding. Jonathan is in the background being, an awesome administrator, assisting me today. And when it comes to roadblocks, we like to tailor the roadblocks specifically to the area of the episode that we're focused in each episode. So in this case with robotics, some roadblocks can be the fear, right? The fear of that new technology, right? The fear of what you don't know at the primary level, or actually at any level. For example, dealing with the lithium-ion batteries, right? Things that can explode or have explosion potential, even small parts when it comes to the primary level, right? Or even when it comes to 3D printing, for example, some of the noxious fumes that come off of the filament. Right? The time that this will take. Right now, we have to admit, educators are swamped. And because educators are swamped, it takes time to research this type of stuff. It takes time to study it, time to implement, right? Good afternoon, Tariq. Mr. Tariq Yerwood. Nice to see you. It takes time to do these things. Again, this is why persons like Jonathan and myself are here. We tend to help with that support. Cost and funding of implementation is another potential roadblock for educators, even for students. Now, we're actually going to address that later on because we're going to show you how you don't have to, spend a whole ton of money in buying robots and in robotics equipment. In fact, if you don't want to, you don't need to spend any, but that might be a stretch. Why? Because you're still going to want to at least spend a little bit, invest a little bit, so you have that over the long term. For those persons who like to touch, who like to, or kinesthetic learners who really like to get involved, as well as those who are, both visual learners and persons who like to touch and try things out for themselves. Support and maintenance, that is access to robots, access to components, access to materials and technical assistance. Again, this is why Jonathan and myself are here. Like I mentioned, schools can feel free to reach out to me anytime. And also, you don't have to be a school located in Barbados. You could be anywhere. It doesn't matter. Shucks. If I have to get a translator, yeah, Jonathan and I will assist you because we know our stuff and we're willing to share it. It's quite okay. Then you have competition. Because you have traditional areas of education, which tend to take up the bulk or the majority of the time, the challenge that you then have is then robotics, which is a newer, more trending area. Even though it's helpful, even though it's useful, you have those more traditional areas seen as more important. But here's the thing. This is where our world is trending. And we mentioned this in episode 1. It would make sense if our world is trending towards robotics or coding, things like that. Yeah, we should be getting our students involved at a very young age. Just like the computer. I got involved with that at a very young age. And now, it's not that I'm an expert at it, but I can find my way around. If I have to research something on my own, I can. And also, I can reach out to other persons in my generation who have also done the same. And more, right? So this is the part that Jonathan loves. There's a reason that I'm mentioning Jonathan's name a lot because I know he's in the background and I know he's not going to run out and say anything, right? He's under heavy manners, as we love to say here in Barbados. But the sweet thing is that this is one of his more favorite parts. All right, and Jonathan is known for really doing the primary level examples, right? The sample class lessons because he's worked with a lot of primary schools. And like I said, we're always willing to work with these persons. I'm laughing at the admin in the background. Okay. So first sample project or lesson. We're looking at the primary level here. So let's look at the topics of energy, forces, the human body, and natural resources. How many persons really looked around them during this in this COVID-19 environment? How many persons recognize that there are a lot of robots around us, even before COVID? But with COVID, you actually see a lot more. Uh, it's become fairly commonplace. Yeah. Now, I don't know if before get into it, maybe you can identify some potential robots in our environment. Maybe you can. Let's see if you do. And feel free to shout it out in the chat. Huh? Okay. So the aim is to review robots around us right now in our environment. And the objectives here, or the objective is to use robots in our daily environment to understand the basics of the same topics I mentioned. All right. So for example, when we are discussing what is a robot, why do we need or use robots, or what can robots do, I'm going to share something with you right now. Let's skip ahead here. Notice anything? Anything familiar? Anything jumping out at you? Do you think it was just simply a hand sanitizer station? Nope, it was a robot. Or they are robots. I'm seeing robots around every day and people are walking by and they just stick their hand under it and they're like, yeah, okay, cool. Spray my hand, Mr. Machine, and let me go on about my business. Yeah, that's a teaching moment for students. That's a teaching moment that educators can use. Those are robots. Yeah? And you can actually use pictures like this. You can point out. So the next time a child goes into, for example, this particular restaurant or goes into a mall and they see something that looks like this, they're like, oh wait, yeah, I remember either in the case, insert your name here, Mr. Educator or Miss Educator, right? That this is a robot, okay? And you can then tell your parents and your friends how it works. Break it down for them. Let them know, all right? So this is one that on the left that I saw in a popular restaurant here. And I love how they branded it. I love it. They were brilliant about this. I think in my mind, the only thing is they say touch free, but you have to put your hand a bit too close to the material. But still, job well done. I love it. Where others just purchase machines and that's it. I find a lot of, in fact, you recognize that you'll see a lot of these hand sanitizer stations, and a lot of companies have branded them. Now, that's a brilliant idea. Easy marketing, right? All right. So then you see something like this. Now, this device, it actually replaced what we call the temperature gun, right? Or the infrared temperature sensor, uh, yeah, or the wireless, if you want to call it wireless thermometer, however you want to put it. Now, for many persons, they didn't like the idea of someone putting something referred to as a temperature gun to their head or even in front of their forehead, in front of their eyes. I've been on a line where a lot of persons complain about this, right? In many lines. But yet you still have the same thing. It's just on the wall. It's hilarious, right? But that's a robot too. So now, no longer do security guards or persons have to be hired to do this. No longer do you need to take personnel useful personnel from their work to come and do this for persons coming through the door. Persons don't need to stop what you're doing in any environment. So I can just walk in and I come close, and it actually is actually more it's actually faster than a temperature gun, which you have to squeeze the trigger and so on. It's actually a lot faster. Um, and so what this does is this takes your temperature. You just go up to it, place your head near to it. You don't have to touch it, and it takes your temperature. All right. But again, a simple picture like this, every time a primary level student passes, they get an idea of what it is. All right. So here's a temperature gun, and you have an idea of what it looks like. And to give you an idea of how it works, it uses a sensor on the inside, right? And that sensor, it basically allows you to. I want to keep it very simple for everyone, not go too deep here, but it really allows you to uh, gain the temperature from a person without having to touch them. Remember, we're in that environment where you don't want to be that touching a person, right? So typically thermometers were such that you have to put them on your arm or something like that. In this case, no longer. All right. But these are the types of things that some persons don't really like. But of course, that would mean then that these ones here, this type on the wall, are probably more expensive if you think about it, because someone doesn't have to hold it, right? And it's, it can plug in, and some of them are battery powered as well. All right, so let's go back. So we're discussing what is a robot, why do we need or use robots, what can robots do? So those three sets of pictures that I showed you give you an idea of the answers to all of those questions. And in terms of resources, STEM tools and resources, simple pictures and videos, like you know how we do here on the STEM in Education series at the EdTech Spot. We're not giving you anything to break the bank. All right, pictures and videos of the robots around us. Okay, recycle materials in terms of making robots, so you don't have to go and spend hundreds of US dollars, or Asian dollars, however, whatever currency, depending on wherever you are. You can use cardboard, corrugated cardboard, which is stronger, rubber bands, old toys, appliances, old appliances, I should say. Don't go and mash up your microwave. Don't go and destroy it. And please don't tell anyone that I sent you to do that. Please don't. You know, um, and old equipment. Okay, I have one student. Persons love to give him all of their old stuff because they get rid of it, and he's happy to get it. The only one who isn't happy is his mom, who then complains to me and says, "Well, Jelani, I have all this stuff all over the house, and he's just constantly repurposing it." But then again, small price to pay for a potential future billionaire. No? Yeah, I think so. All right. Then basics of machines, design, and power. Now, looking at simple machines, machines that push, machines that pull, machines that lift, machines with gears. Simple basics like these are good at that primary level. Okay? And that's where the old toys and appliances come in. All right? And of course, you have some electronics like robot controllers, which allow you to program robots, or actually just program them. And then you can have electronics connected to them that actually actuate or produce some type of output or action. Okay. And then you have wireless toys, like a lot of these RC cars and stuff like that. Again, back with the old toys. Yeah. Using those remote controls, right? Um, Very, very useful. And persons throw away a lot of this stuff. Again, all stuff which I have repurposed and my students repurpose. You have mobile devices, okay? When you think about your cell phone, your tablet, your laptop, these are all tools and resources that that you already have, you already need for this current blended learning environment that we're in. So you don't have to spend any excess money, okay? And these are things you can use with the same pictures, with the same robot controllers. Tinkercad, we mentioned that in previous episodes, episodes 3 specifically, where we dealt with 3D design and 3D printing. Okay? In fact, we can take a quick look at it right here. We can take a quick look at it. Let me just share. And what I'm going to share with you is going to allow you to be able to see what we mean when we talk about using 3D design here, where we use Tinkercad when it comes to this type of content in robotics for students. All right. So here we go with Tinkercad. All right. And now notice here you actually have Tinkercad where you have 3D designs. Okay. So at the primary level, even if they can't do the 3D designs themselves, you can still show it to them. Okay. You can at least show them these 3D designs. You can show them how they look, how they operate. Okay. And then of course with 3D printing, you can do the same thing. Here you have circuits, right? Tinkercad circuits. And you have simple circuits. So for example, if you look at this is a simple circuit where we just connected a motor to a battery. It's nothing difficult, okay? Simply. And this is something that I'm sure almost everyone who tinkers would have at least done once or twice. I mean, we're talking about persons who like to, lick batteries, right? Just to feel that little shock. Yeah, sounds weird, right? But again, we're talking about future trendsetters, persons that are very interested in technology, okay? And then we have code blocks right here, Tinkercad code blocks. Tinkercad code blocks is actually very useful in the same robotics because it actually helps with the 3D design aspect. It shows those young students at the primary level how they can really create a 3D design by removing materials. So for example, if you would allow me, let me play this for you. So what we're using here is code, like we use for robotics. But if you look here on the side, I'm going to slow this down so you can see it carefully. So notice that we're creating a table here. So let me play that again. So we started with a cube, all right? We raised it a little bit. We created another cube that acts as a whole and removed the material. Okay, so all of that helps with the 3D design, which then helps with our 3D printing. In fact, in general, it just helps them to visualize how we create a 3D design, how you can create a component for your robot, which is going to be useful at other levels. All right, so let's remove this and let's get back to our presentation. Uh-oh, it seems that I have stuck. All right, so let's give us a second here. And we'll just give it a second to get back up and running. So let's see if we're still having the same problem as before. And it seems like we are. So just give us a few minutes to solve the problem. As these things do, they love to wait until you're in a lovely presentation mode, until you have a lovely flow, and then they just give it to you. But that's how it is in tech. Hi everyone, sorry about that. So this is what it is like to be a techie in tech life. This is how things go. These are the challenges that you can have. All right. So I do believe they had the video with Mr. Jonathan Gardner, one of my students. So let me actually share my screen again and present. All right, and we're back. We're back and ready to go. All right. So let's get back to where we were. We were at the secondary level, and we were talking about we're at the secondary level at that particular project, and we were moving on. Okay, so here's what we're going to do. We're going to focus on the topics of biology, physics, industrial technology, technical drawing, mathematics, art and design, engineering, technology, all of these topics in one. How are we going to do this? Easy. So the aim here is to focus on 3D design and 3D printing within robotics as it relates to these topics. And it can be done. So for example, the objective here is to use 3D design and 3D printed tools and resources to create structural components to upgrade robots. All right, remember what I said. If we start showing them, for example, 3D design from young with the Tinkercad code blocks, we can then actually move forward. We're at the secondary level. We can now get into using 3D design and 3D printing to create components themselves, right? So where they can actually see the results of their own designs. Okay, so for example, in our discussion, we would discuss things like what type of robot would you create? I mean, you have the tools that are available to you in terms of 3D, 3D design, 3D printing, and so on, right? So what robot would you create? What task would you create your robot to do? Now remember your topics, okay? Remember your topics that I mentioned earlier. We're talking about biology as well here. We're also talking about art and design, okay? How would you upgrade your robot? Now, upgrading your robot, you can upgrade a robot or even create robots, okay, using that same 3D design, 3D printing, as well as some other STEM tools that we're going to show you here. Remember, I showed you Tinkercad, 3D design, and 3D printing, as well as circuits, as well as code blocks. Now, within Tinkercad, within circuits, you can actually also do or use code. Okay, so I'm actually going to show you a little bit of that. All right, so let's close down a few things here to ensure that we don't have the same problem like we had before. So we're definitely trying to prevent that. Okay. And what I'm going to do, I'm going to stop sharing my screen for a second, and I'm going to share something else that I think everyone here will enjoy. So I'm sharing my screen. Just waiting on admin to pull it up. Just ensuring there's no issue with the screen share. All right, there we go. Lovely. It takes a moment, but the tech gets there. Trust me, the tech always gets there. Doesn't have a choice, right? Okay, so to give you an idea, this is a circuit that was created by my students. This was in 2019 at the Barbados Junior Robotics Camp. Now, if I click Tinker this and go into this actual circuit, what's going to happen is it's going to allow me to be able to create code. Why? Because I actually have what is called a controller, a microcontroller, this part right here. Okay. So what I can do, I can actually click code. And now I can actually code, for example, using blocks. All right. Tinkercad is very useful. Trust me, very, very useful. I can actually code in here. We can code using blocks, or we can code using blocks and text. Okay. So this way, for example, with let's say you're transitioning a primary level student to a secondary level, the sweet thing is now is that you can actually show them what blocks of code represent or represented in the text. All right. So then we also have text. So it's asking me, am I sure? Because it's very difficult to go from the text back to the blocks, okay? Sometimes they're not always interchangeable depending on how you write your text code, all right? So looking here, again, you can actually, like I said, you can actually code from in here. So what we're really saying is here, you can actually prototype an entire robot without having the robot. I hope everyone gets this. Jonathan and I have said from the beginning, we're not out to try to sell you on, spending a whole bunch of money for your school. Sometimes we're just showing you some cheaper tools or tools that are free, right? And in this case, this is free. This is nothing you have to pay for. Hopefully, Autodesk never makes you pay for it. Hopefully, yeah. And with COVID, it doesn't seem likely. Yeah, hopefully not, right? Okay. So here we are back to our presentation. Now, you might remember Object Viewer, which is here at the bottom. Object Viewer right here, okay? And Object Viewer, I'm going to show you what that is because I want you to see what we have been showing you all along, which comes in handy now. Remember this, Object Viewer? Remember this from our episode 2, where you can quite literally take a physical object in your hand, and you can actually view a 3D object that you have designed in your hand. You can turn it around, you can see it all over. That's great at the primary level, at the secondary level, at the tertiary level, at any level, even if you're a hobbyist, okay, which I am partially. Even if you're a DIY type of person, yeah, this is for you, trust me. All right. So then also at the secondary level, you still have electronics like robot controllers, okay, and mobile devices. Like I said, you have your mobile devices. Remember Science Journal, the Science Journal app? Yeah, that actually works with some of these microcontrollers. So now you have your phone, you have an app like Science Journal, and you can actually combine them. Yeah, so the only thing that's really costing you anything is that microcontroller. And if you don't want to use that, you can still only use the Science Journal app if you decide to. Okay, then you have Thingiverse and YouTube. So I'm going to show you a few things here. And what I'm going to show you are some microcontrollers that can be used. Here they are, some microcontrollers that can be used with robotics at the secondary level and even at the primary level. You have some that are even plug and play. All right, let me backtrack a little bit. I don't want anyone to get, into the mindset of any of these roadblocks. Don't get fearful. Don't, and I mean, you shouldn't be too worried about cost because we've been managing that for you in this presentation. Okay, we were not trying to set up your equipment bill at the school, right, or even personally as an educator. All right, so you have persons like myself and Jonathan who can actually assist you with this. We provide technical assistance. We're not trying to sell ourselves here, at least not to that level. What we're really just trying to do is share with you that we can assist. Okay? If the content is too much for you, we can assist, and we're willing to assist. All right? You just have to call on us, reach out to us at the EdTech Spot, or you can reach out to me at Jelani Payne. Okay? All right. So this is one particular type of controller, but then there's another one, and this one is actually quite. I'd call it stronger. It's more like having, let's say, a small personal computer, right? Which is quite cool. That's the Raspberry Pi. What I showed you before was the Arduino. And as you can see, it has a bit more, right, to the actual circuit board. Yeah. And I mean, this thing is pretty powerful. Okay. In fact, there's quite a lot in robotics that is pretty open source and is available and not hugely expensive. We're talking inexpensive stuff here. We haven't gone over 50 US dollars yet. Okay. So what we're really seeing here is there's a lot of powerful equipment that can be used at these various levels. All right. And we're just sharing with you some examples. Thingiverse. You would have seen Thingiverse before, but just so that you have an idea, because persons may not have seen, let's say, episode 3, where we did 3D design and 3D printing, here you have Thingiverse, okay? And you can actually 3D print, or rather, you actually have 3D objects here, okay, in terms of equipment that you can 3D print, all right? And this is basically what we would call a repository, or rather an online storage, cloud storage basically, of various 3D designs. And persons upload stuff here all the time, and you can come on here, you can download that 3D design and you can print it. All right? Okay. And of course, YouTube. YouTube is pretty interesting because once you do a search, it can take you down a rabbit hole. Right now, this is actually something I want to build, but persons all over the world in robotics, all the hobbyists, even young students, have been building this, right? An automatic, an automatic hand sanitizer dispenser, even soap dispensers. It's really very cool and it's very, very interesting. All right. And that's just YouTube. Makes it so easy. This is nothing that you have to go and pay to go and find or see. And of course, again, you contact us here at the EdTech Spot, myself and Jonathan, and we can share some of these resources with you. And typically, we actually share these resources on our website as well as the slideshow, this presentation on our website. And that way you can actually just go through yourself at your own pace. So here's that project that I worked on with my students from the St. Michael's School, where we upgraded a robot. So this isn't how this robot actually looks, okay? So typically, it doesn't have this claw in front, and it doesn't have this light on top. But simply by 3D printing these parts, these parts, we're actually able to, upgrade our robot. We can design our robot to do any task. So in this case, we designed it to grab objects or bite, right? And then also we provided a structure where we can actually have a light on the top of the robot. Yeah. Again, upgrading the robot, something which wasn't there before. So here's the secondary level. Again, I found this pretty useful. I find robotics pretty useful, especially at the primary and secondary levels. I mean, at the tertiary level, it's compulsory, right? It's just a part of the programs. But at the primary and secondary levels, it's very useful for the reasons that I would have mentioned with robotics in education in that earlier slide. So let's introduce students to wireless communication. This includes physics, mathematics, agricultural science, all of these various things. And in this case, what we're going to do is upgrade a robot again to be teleoperated using Bluetooth wireless technology. Okay, so what wireless technologies are available to control your robot, for example? And you have, normal radio frequency. You have Wi-Fi, right? You have so many different types, okay, of wireless technologies that are possible. But they have different ranges. For example, again, part of the discussion. So which one would you use to build your particular robot? Okay, depending on what it's supposed to do. Notice how we are reverse engineering the process. 3, in terms of discussion, how would you best use one of these technologies to control your robot, right? Well, if you have Wi-Fi, Bluetooth, you have radio frequency, well, I mean, there are lots of options here, right? Okay. So in this case, the resources that we're really talking about or your mobile phone, a tablet, okay, and some wireless modules. You wouldn't believe me if I showed you the price of wireless modules. Again, we're not even passing 20 US dollars, I think. Not even, and when I say I think, I mean I think because as far as my research shows, you can get them for even lower. And then you can still use recycled materials like corrugated cardboard, hard plastics, old toys, old appliances and equipment. Okay? So let me give you an example of what we would have done here at well, with some of my students, okay, at the Barbados Junior Robotics Camp, hosted by the Caribbean Science Foundation. Here we have a robot arm. So we built the arm, and then we have some options. It could be teleoperated, where we're using radio frequency, we're using Wi-Fi or Bluetooth. We have some options. Okay. In this case, I'll show you what we did. So let me actually stop the presentation for 1 second, and I'm going to share the screen again. I'm going to ensure that I'm sharing my audio because I hope that you can hear it. And we're going to ensure the volume is turned up. So I just need admin to, right, so we'll have to play the video here. Just ensure the volume is up.
No, what you okay, sorry.
So you kind of get an idea here of how much fun I have with the students, right? And how much fun they have. Now, that's one of my students, Justin. Justin is very deep into coding, for example. But he relented and he got into robotics with me. And what you're seeing there is we are controlling a robot arm wirelessly. Okay, that's via Bluetooth. So you see that wire coming out of Justin's, well, the glove on Justin's right left hand. Yeah, all that is connected to is a power source in his pocket. That's it. That's not connected to that robot arm in any way aside from wirelessly. All right. At the tertiary level, and this is one of my favorite things that I've ever researched in terms of biomedical engineering. It was even something that I wanted to do. I'm already a multidiscipline engineer, but let me tell you, biomedical engineering made me want to go back to school a little bit. Yeah. Prosthetics and orthotics. This was an area where at least two students I've known, 2 or 3 students, were interested in, but they didn't know what to call it. Right? They were talking about, oh, I'd like to make prosthetics. But when you research prosthetics or just making prosthetics, when you go online, it's not that it's not widely provided as a program, a standalone program. Very, very few universities. But within biomedical engineering, yeah, that's a big part of it. That is a big part of it. Prosthetics, this is the replacement of limbs, right? Orthotics, this is the support of limbs or support of the body structure. And the aim here at the tertiary level is to convert physical disabilities to superhero abilities. What do I mean when I say that? Use trending technologies to create innovative solutions for the physically disabled. Now, it might seem like we're going really deep, right? Except let's make it very simple. What trending technologies in our discussion can be used to innovate prosthetics and orthotics? Okay, 3D design and 3D printing. We already shared that with you. Robot controllers, Arduino and Raspberry Pi. Circuit design, Tinkercad, right? Where we have Tinkercad circuits. AutoCAD. AutoCAD is actually free. When I say free, initially I always thought AutoCAD was something that was paid, but if you are working with an educational institution, it's not. Or if you want to use an educational version, it isn't. It's actually free. Okay? Well, at least but I last used it, and this was late last year into this year, so it should still be free. Autodesk hasn't treated us too badly. So to give you an idea, here is what you can see is an orthotic. Okay, you put your foot in it; it helps to support the foot. All right. Um, or note, now this is a solution that can be 3D printed. For example, it seems like I'm mentioning 3D printing a lot. That's because within robotics, it's extremely useful, and extremely valuable. Here's a robot arm. Imagine making a modular robot arm. All right. Now this is all biomedical engineering, and this is all robotics. Right. This is all robotics. Sure, nanotechnology and all of those other things are part of it, but so is this. Right. And in this case, when we're looking at these few tools and STEM resources, a lot of these are what you really need. A lot of these are what are useful. And in terms of what is used at a tertiary level, sometimes you're just using what you would call not even an upgraded version, but a paid version or a more functional version, a version that has more features, but based on these same types of equipment, based on these same tools and resources. Now, we actually have a few guests for you, okay? And first up is Mr. Jonathan Gardner. Now, Jonathan is a tertiary student. He's actually at the University of the West Indies, St. Augustine campus, and he's studying mechanical engineering. He's one of my students from the that same summer camp, the BJRC Barbados Junior Robotics Camp, hosted by the CSF. And Jonathan has been kind enough to record a brief video um, sharing his focus in terms of robotics, why he got into it, um, you know, at least with me, and then how can I say this, how it drove his decision making or reinforced it. So we can actually play that video now.
When? Good day, all. My name is Jonathan Gardner, and I am a Year 2 mechanical engineering student at the University of the West Indies, St. Augustine campus. I would have met Coach Jelani when I was partaking in the BJRC robotics camp at level 3, which is now level 4, in 2018. While partaking in the camp under Coach Jelani's tutelage, I would have learned various skills and general information, as well as the application of robotics in today's society and how it will advance the future generations as the Caribbean seeks for sustainable development and other goals. My experience with Coach Jelani was able to teach me a lot, but the most important skills I would have learned from watching how he operated as well would have been how to work in a team and be dedicated to working with other problem solvers in this field to find solutions. In terms of how he has influenced me career wise, I don't think it was so much to make a change. However, what my time with Coach Nani did for me was confirm that mechanical engineering and robotics was the direction that I wanted to carry my life in the future. When?
And so that's one of my students, Jonathan Gardner. And we actually have another one here, another video that I'm going to play for you. But that was one of my students, Jonathan Gardner. And uh, notice what he said. Notice he said that robotics helped reinforce the things he wanted to do. That's the really sweet and great thing about robotics because it encompasses so many different areas. Um, it allows students to then say, okay, this is not for me, or this is for me, but in this quantity. or I like this particular part of robotics. Like I mentioned, Justin with the Bluetooth wireless, the wireless Bluetooth control arm. Uh, Justin, Justin loves programming. Justin is a hardcore programmer. He was doing it even before he came to me in robotics. But at the same time, um, it still helped reinforce his love and his passion for coding and how we can utilize coding with hardware and not just pure coding itself. All right, so let's go over to Mawali Knight, or rather, sorry, let me say that right, because he'll be upset with me if I get it wrong again. Mawali Knight, okay, and he's a tertiary student. Sure, he has on a uniform there, but Mawali is actually at the University of the West Indies, Cave Hill campus, and he's studying computer science. When I last spoke to Mawali, his focus, as I recall it, was on human resources, if I recall, and some other area, but I definitely don't recall computer science at all. Oh, it was on economics. Yes, he was interested in economics. So it's a treat to hear that he's interested in something else. But I'll share the video, and this way you'll get to hear for yourself. All right? So let's play.
Good day. My name is Mawali Knight, and I would have met Coach Jelani Payne last year around summertime at a Level 4 robotics camp hosted by the Caribbean Science Foundation. Our relationship, and through me interacting with him, definitely further enkindled my passion for technology and STEM related fields and activities. During sessions under the tutelage of Coach Jelani, I developed a greater appreciation for the tools and knowledge I acquired from studying physics and math, among many other areas. As sessions with him allowed me to practically apply what I learned from courses like these. Sessions with Coach Jelani were fun, educational, and interactive. There was never a dull moment. Some of the reasons I enjoyed working with Coach Jelani and look forward to working with him in the future are that he is extremely thorough, always willing to assist whenever and wherever possible, and he breaks down and articulates topics exceptionally well. As a result of attending those sessions with him, robotics has transitioned from a field I knew very little about to it now being a passion of mine, especially innovative robotics. Furthermore, as a result of these sessions, a whole new side to the world around me was revealed. I'm currently at the University of the West Indies, and I am studying computer science and accounting. Me choosing computer science was due in part to Mr. Payne laying bare a lot of the possibilities that can arise from learning about technology and STEM related fields. A future profession I see myself in is software engineering. To really see the importance of STEM related fields, just look to Singapore. Students in Singapore are privy to learning how to code at school as early as 3 years old. According to the US Bureau of Labor Statistics, the computer and information technology field is expected to grow by 13% from 2016 to 2026, faster than the growth rate of all occupations. By 2026, another 557,100 jobs are expected to be added within the field. End quote. In addition, according to research conducted by Korn Ferry, a consulting firm, they predict that in this year alone, the technology, media, and telecommunications industries may be short more than 1.1 million skilled workers globally, and that by 2030, this deficit could increase to 4.3 million. End quote. Let that sink in. It is therefore clear to see the world needs more STEM savvy catalysts. Catalysts being people, and consequently, it is imperative that my peers play their part and that governments create environments which foster a love for STEM related fields. Earth needs people like us now more than ever. Thank you.
So Mawali is a brilliant guy, and we've had some pretty interesting conversations. And I remember Mawali actually reached out to me, and he reached out on the basis of discussing future careers and so on, right? Um, because there's a trajectory that he was on, and then, you know, things changed for him, and he was wondering, well, what to do next. Yeah. And this is something that I've done before, and I typically do consult, or other students consult with me, and we discuss, their future, their careers, studies, professions, etc. And Mawali was interested in economics. I can't remember the other area, but it wasn't computer science. So the cool thing about it for me is in him saying that there was this impact that robotics, sure, I was a part of it, but his exposure to robotics showing him, in his words, showed him, introduced him to a whole new world that then got him interested in computer science in an area that, as he has rightfully said, is growing at an alarming rate. We actually have another student of mine, but this time he initially hailed from the St. Michael's School. I would have met him in 2017, and I would have met him through the school, through the St. Michael's Secondary School. And he was always one of those that faithfully came to the Friday weekly sessions for about an hour and a half. And he was always one to ask me a lot of questions after. He always had a lot of ideas. He would always say, well, sir, because back then, I would be sir, right? Makes me seem old, but back then, in secondary school, that's what they call you. So he said, sir, what do you think about XYZ? Do you think this would work? I mean, we have talked about things from wireless charging, right, to upgrading the school lighting system in terms of motion control, and in terms of wireless control. And it's the coolest thing ever that he has now come all this way. He's now at university in his second year, and he's doing something with the knowledge that I would have shared with him. But also, he's actually started his own podcast, and he's going to actually talk a bit about it. So I'd like to welcome Mr. Jelani Maynard.
Hey, good afternoon, everybody. Thanks for having me on the show again. So, yeah, as Jelani was saying, I met him through the robotics sessions that he conducted at the St. Michael's School in 2017. And I'm also a podcast host, as well as a university student in my second year, pursuing a degree in electronics. So, on my podcast titled Circuits of Change, you can follow the Instagram account for that. I discuss the various advancements in technology today. It could be drones, virtual and augmented reality. It could be 3D printing, anything like that. And I discuss how their applications can be used here in Barbados. Whether it is to create an industry, so, extra job markets, all of that stuff that can help push our society forward. Now, my experience with Jelani going to those sessions, he made the topic of robotics very interesting for me to learn and to ask questions about when it came to designing a robot or programming the robot or building the robot. All of that helped me to decide on my career. So before I met Jelani, I knew that I wanted to go into electrical and computer engineering, but that's still pretty general. So attending those sessions helped me to refine it down to electronics engineering, which led me to pursue the degree that I am currently studying now. So yeah, also attending those sessions helped spark that innovative thing in me to give me all the ideas that I would talk to him about. And that spark has been there from the time I met him to the time to now, whether it's in research or anything like that. So thank you again for on the show, and thanks for changing my life, man.
Absolutely, Jelani, absolutely. And with his podcast, Circuits of Change, Jelani just finished. Jelani Maynard. By the way, I purposely did this because I thought it would be something that person would enjoy seeing that even though the name is not the most common name, that is Jelani, at the same time, there are other persons who have it, and they're into the exact same thing that I am. I love it. But in his podcast, Circuits of Change, and you can find Jelani Maynard at Circuits of Change, you'll find he just finished his first season 1 of his podcast, focusing on drone technology. And it's interesting. And I really wish he could share more, but I'll have to just revert and send you toward his podcast, at Circuits of Change, which he actually breaks down things like using drone technology for security, as well as lots of guest interviews, even talking about using drone technology within agriculture, which is something that's already used, in other parts of the world. So, Jelani, absolutely thank you for coming on to the show. We appreciate you, and we look forward to having you on possibly in the future.
Of course, no problem.
All right. So at this time in the podcast, it's the Q&A segment. Okay, and we of course hope that persons have their questions ready, and please keep them brief. But feel free to ask us anything that is on your mind as it relates to today's episode, or even previous episodes. We'll at least try to answer your question, whether we answer it live, or we can always answer it in the comment section, or if you reach out to us and contact us directly at the EdTech phone. So, does anyone have any questions? It seems like we have an automatic door question. Is an automatic door a robot? Yes. Simple answer, yes. So, in fact, let me say this. I would love for school to call me and let's do a tour. We'll do a tour of a normal office building, or right? And by the way, this is in direct response to Tariq Yearwood's question. Is an automatic door a robot? I would love for school to give me a call at the primary level or even the secondary level, and I can do a virtual tour, or I can have to do it physically. It's going to be a bit difficult to do it physically, but the sweet thing about it is there's so many real life robots. Every time you walk up to an automatic door, there has to be a sensor, because remember, if you think about it, that automatic door has to know when not to shut on you, okay? To not, chop off your foot, right? So, that's one of the great things about the robots around us, right? So remember, I think this was part number 3 or 4, the very first thing I mentioned about what is a robot. Yeah, a robot can react to its environment. It can actually communicate with its environment. So that there's a sensor on the door, it sees me, or rather it sees my motion, it sees my movement, it sees that some set of information has changed, and it communicates that to its brain, the robot brain or the controller, and then it automatically opens. And once it's not seeing that information anymore, it closes. Any other questions? I love questions like that. I wish we got a few more. A few more. So we always encourage our viewers to join our professional learning networks. This is while we're waiting for some more questions. And these professional learning networks, for example, are the Google Educator Groups. So that's GEG, Google Educator Groups, otherwise known as GEG. And you have GEG Barbados, Bermuda, which launched last night. You also have GEG Caribbean. So these groups actually support, or rather they are a support group for educators, as well as tech-savvy persons, okay, ICT professionals, and for example, persons who are just interested in assisting educators, assisting their children, and so on, and assisting students. And basically, with GEG, that support group is a support group for persons who use Google for education products, like the apps, as it relates to learning. So, are there any more questions? It does not seem that way. But you know what Jonathan typically always says? His favorite line, or one of his favorite lines is, Once we have not received any questions or any more questions, we take that to mean that we've done an excellent job. We have actually answered all of your questions before you have had to ask them. And, we're just happy that we could be of service and share the content with you. Okay? So we hope that after today's program, that you're inspired to learn more or begin developing your own STEM learning environment. So I invite you to carefully consider the context and conditions that students thrive in. Okay? And when we talk about this context and conditions that students thrive in, so this is actually outlined in the COVA approach, not to be confused with COVID, the pandemic. Okay? So the COVA method asks that educators, give your students a choice, the freedom to organize, structure, present their ideas, and learning in the classroom and virtually. I believe robotics does quite a bit of that. Give your students a choice, the freedom to organize, structure, present their ideas, and learning in the classroom and virtually. Again, if you think about robotics, which blends that design process, that's a big part of it. Okay? Ownership. Allow students to take ownership. This comes with the freedom of choice in what they want to do. Let them choose tools to build, engage, motivate, and become self-regulated. Okay? Also, give students a voice. Also, give them purpose. Help them to define their personal significance and what they are doing. Help them to define their personal significance and what they are doing. I read that wrong. Don't know why. Okay. Provide regional and global sharing opportunities and ways to revise and structure their ideas through testing and experiments. Also, and finally, provide opportunities for authentic experiences through STEM learning. Let them select projects that can become real-life solutions in their world. I don't know about you all, but I kept hearing robotics through all of that. All right. So the COVA approach complements the STEM and blended learning method in facilitating student-centered learning, guided inquiry, discovery learning, project-based learning, peer collaboration, and creativity, all of which combined can provide greater balance and structure to learning that can lead to infinite possibilities, which is exactly what we want, of course, as educators. Okay? So, before we close out the session, I just have to ensure that we share our contact information. So, I'm going to share myself first, and then us here at the EdTech Spot as well. So you can connect to me at Jelani Payne at Instagram, right here, or LinkedIn. You can email me at my name, jelanipayne@gmail.com. Then you also have Robot Adventures, which is that 100% online STEM robotics program that is currently running. Okay, and these are the robots, or rather the robot that we'll be using in that particular program. And then you have JP Robotics, under which I do coaching, showcases to schools, club setup for schools, and so on. Yeah, even private events. So feel free to reach out to me. But of course, we cannot complete this episode without mentioning the EdTech Spot. This is our platform at the EdTech Spot on Instagram or at YouTube, this platform which we're sharing this information to you on. So you can also reach out to the EdTech Spot at the edtechspot@gmail.com. And at the EdTech Spot, we don't just do the STEM education series, we do quite a bit. So we actually do teacher training, consultations, and tech boot camps, especially if you think about it, this works well during this blended learning environment, or even if you're doing a purely virtual environment. Okay, so we've come to the end of this episode. I would like to invite you to subscribe to our channel to stay up to date with our releases of new content. This episode, sad to say, will be our final episode for season 1 of the STEM in Education series. Now, season 2, we're coming back. Season 2 is set to begin in January 2021. However, we won't be leaving you to navigate the online classroom and this blended learning environment alone. We'll still be providing you with great content to help you learn and master your new online teaching and learning tools like Google Suite and Google Jamboard. To everyone who's watching, please thank you for watching. Thank you to all the viewers. And until next time, stay safe.